Welcome back. This is module 7 in our programming basics playlist. If you have been following along and trying out any of the examples yourself, chances are you have already run into an error message or two, and that's completely normal. In this video, we are covering errors and debugging, what actually goes wrong when code breaks, the different types of errors you will run into, and a real strategy for actually fixing them instead of just guessing. So we will start with what a bug actually is, then walk through four major categories of errors: syntax, runtime, logical, and compilation errors. After that, we will get practical, covering what debugging actually is, a step-by-step strategy for beginners, how to actually read an error message, and finally how to test a program to catch bugs before anyone else does. So starting with the basics, what exactly is a bug? A bug is any mistake in a program that causes it to behave incorrectly or stops it from running at all. The really important thing to internalize early is that bugs are completely normal. Every programmer at every skill level writes them constantly. Finding and fixing bugs isn't a sign of failure. It's a core everyday part of programming. Then the term bug became popular after a real moth was found stuck in a relay of the Harvard Mark II computer back in 1947. Engineers literally had to debug the machine, pull the actual bug out. The name stuck ever since. Then going through the different types of errors you will encounter, beginning with syntax errors. A syntax error occurs when code breaks the grammar rules of the programming language and is code before the program ever runs. Look at the example. We have an if statement, but we are missing the closing end if. Notice the error message that comes back. Syntax error, expected, end if, reached end of file. The language is telling us exactly what structural rule got broken. Common causes of syntax errors include missing brackets, missing quotes, missing keywords, or misspelled keywords and mismatched parentheses, something like that. Small structural mistakes that break the language grammar. Then runtime errors, a completely different category. A runtime error occurs while the program is running. The code is grammatically valid, but something goes wrong during execution. So we set a equal to 10, b equal to 0, and then try to calculate the result equals a divided by b. The syntax here is perfectly valid, but dividing by 0 causes a crash while the program is actually running. Notice the error, runtime error, division by 0. Common causes of runtime errors include dividing by 0, accessing a missing file, or using a value that doesn't exist yet. The key difference from syntax errors is that the program actually starts running before this kind of errors show up. Then logical errors. A logical error means the program runs without crashing but produces the wrong result due to a flaw in the underlying logic. So take a look at this buggy average calculation. We have a equals 10, b equals 20, c equals 30. But look closely at this line. Average equals a plus b plus c divided by 3. Because of how the math works here, only c actually gets divided by 3, not the whole sum. So instead of getting 20, which is the correct average, we get 36.6. So the idea that makes this so dangerous is that logical errors are often the hardest to catch because there is no error message at all. The program runs fine, it's just wrong. You have to actually verify the output yourself to catch these. Then we have compilation errors, which connects back to something we covered in module 1. A compilation error is any error that prevents the compiler from successfully turning source code into an executable, including syntax errors and certain type mismatches. So look at this pipeline. Source code goes into the compiler, and if something's wrong, the compilation error gets caught right here before an executable is ever produced. This only applies to compiled languages like C, C++, or Java, where code is translated before it runs. Interpreted languages like Python catch similar problems only once execution actually reaches that specific line, not all at once, upfront. And now we have covered different types of errors. Let's talk about the actual process of fixing them, which is debugging. Debugging is the process of finding and fixing bugs in a program, identifying what's going wrong and correcting it. So why this skill matters so much? Every programmer debugs code constantly. It's not a rare event, it's a daily skill. Good debugging saves enormous amounts of time compared to randomly guessing at fixes. And understanding why a bug happened also helps you avoid writing similar bugs in the future. And I want you to really hold on to that. Debugging isn't a sign that something went wrong with you as a programmer. It's simply a part of how programming actually works for everyone at every level. So how do you actually approach debugging in practice? Here is a simple structured strategy. Step 1, read the error message. Step 2, find the exact line it's pointing to. Step 3, isolate the problem, which means narrow down exactly what's causing it. Step 4, test a small fix. And step 5, rerun and confirm it's actually solved. A few extra tips that makes a huge difference is that change one thing at a time, so you actually know what fixed or broke the program. Use output or print statements to check what values variables actually hold at each step. And if you are truly stuck, try explaining the code line by line out loud. This alone often reveals the bug because you catch yourself saying something that doesn't actually make sense. Then we have one more strategy, actually reading an error message properly. Error messages look intimidating at first, but they are actually trying to help you. Look at this example. File app.py, line 12 followed by 0 division error. Division by 0. Let's break this down. The file name tells you which file the error happened in. The line number tells you exactly which line to look at. And the final part tells you what kind of error occurred and why. Always read error messages from the top and focus on the file name and line number first. That tells you exactly where to start looking instead of getting overwhelmed by whole message at once. Hope you understood that. Then testing a program, which helps you catch bugs before they even became a problem. Testing means deliberately running a program with different inputs to check whether it produces the correct output every time. So look at the simple test table. We test 5 and 3 expecting 8. Pass. We test negative 2 and 7 expecting 5. Pass. We test 0 and 0 expecting 0. Pass. Then we also test A, B, C and 3 expecting an error and this one fails, revealing a real problem in how the program handles unexpected input. Always test normal cases and also edge cases. 0, negative numbers, empty input, unexpected types. Catching bugs through testing like this is far cheaper than letting users find them first. So we can recap everything we covered in this module. A bug is any mistake that makes a program behave incorrectly and every programmer writes them. Syntax and compilation errors are caught before running. Runtime errors happen during execution and logical errors gives no warning at all. Debugging is a normal structured process. Read the error, isolate the problem, test a fix and confirm. And testing with normal and edge cases helps catch bugs before anyone else ever sees them. So this wraps up our module 7. In the next video, module 8, we are finally getting into control flow and conditionals. Like I always say this, but we have some more things to cover up each time. That's why we are postponing the control flow and conditionals every time. So where we will learn how programs actually make decisions using if and else statements. If errors feels a little easy now, drop a like and I will see you in the next one. Thank you.